Bismillahirrahmanirrahim. We are still discussing the inverse functions. In the first part, we said that the function or a function has an inverse if and only if it is one-to-one. If and only if it is one-to-one, and we define the one-to-one, it means that every element in the range of the function has only one pre-image, or if we use the horizontal line test, it will intersect the graph of the function exactly in 1 point, not more. If it is intersecting the graph in more than 1 point, then the function is not one-to-one. Now, we are going to give more detail about this inverse function in this part. We're going to speak about the composition of inverse function property. And we said that if f is a one-to-one function, must be there. If f is one-to-one function, then f to the power minus 1. This is the notation for the inverse function. F to the power minus 1 means the inverse function. Then the inverse function, or f to the power minus 1, is the inverse function of if and only if two conditions must be satisfied. The first condition, if composite, f inverse, because this is composite of x, or it's written as f of f inverse of x equal to x. This is for all x in the domain of inverse. So for any x in the domain of the inverse function, if composite, if inverse will give me x, we must have x. It is like that we are moving from 1 point going to, let's say, from A going to B, or let me call it x. X will go for f of x. Now, if we reverse the direction from f of x to going back, I will get x, and this is the meaning of x. So f, and this is f inverse. So x will go for the image, which is f of x. Now, if we reverse the direction of the arrow, f of x will go for x if we apply the inverse. So it is like a rounded trip from x and going back to x again. If this is satisfied, if it gives me the x at the end, then the first condition is satisfied. Second condition, if we reverse the composition, number 2, if f inverse composite f of x, which is equal to f inverse of f of x equal to x. This is for all x in the domain of f in this case. So if these two conditions are satisfied, I got x in both cases, then we say that f and f inverse are inverses of each other. For example, check whether the given functions are inverses of each other or not. Number 1, with that f of x equal to 4x. Second function, g of x equal to x over 4. We need to check, are these inverses of each other or not? Means that I need to check the two conditions, are they satisfied or not? So I have to apply the first condition, which is A or f of x, f composite g of x is equal to f of g of x. Now this notation means I'm going to replace any x in the function f. I'm going to use the external one. Any x in the function f, I'm going to replace it by g of x. I have 4x. It means 4 multiplied by x, which is gx. I'm going to replace it by g of x. Replace any x in the function by g of x. This is equal to 4 multiplied by. Now g of x is equal to x over 4. So replace g of x by 4. Now 4 will cancel with 4. I will have x. So the first condition is satisfied. I got x. Now let's move to the second condition. Let's reverse the order. I'm going to find g composite f. It means g of f of x, which is equal to g is given by x over 4. Replace any x by f of x. So this will be f of x divided by 4. So f of x is equal to 4x divided by 4 is equal to x. So again, it is satisfied. Means these two functions are inverses. We can say, yes, they are inverses of each other. So this is the idea of the composition of inverse function property to check whether the given two functions are inverses or not. Find f composite g. If we got x, then we move to the second condition, which is t composite f. And if we got x again, then these are inverses of each other. Let's have another example. Number 2. About that f of x equal to 3x plus 2. And g of x equal to 1/3 x minus 2 over 3. So let's check whether these two functions are inverses or not. So first condition, I have to find f composite g of x. This is f of g of x, which is equal to. So I'm going to replace any x in the function by g of x. So this will give me 3 multiplied by g of x plus 2, which is equal to 3 multiplied by g of x equal to 1/3 x minus 2/3 plus 2. Now distribute the product. 1/3 times 3 equal to 1 and times 2/3. So this will give me 3 multiplied by 1/3 x minus 3 times 2 over 3 plus 2. We simplify it. I will get 3 over 3 cancelled. The 3 with the 3 will be cancelled. I will have x and 2 with minus 2. This will give me 0. I will have only x. So the first condition is satisfied. Now for the second condition, B, find g composite f of x. This will give me g, which is equal to G is given by 1/3 x, which is this one. So it is 1/3 multiplied by x. X will be replaced by f of x minus 2/3. Now, f of x is equal to 3x plus 2. So this is 1/3 multiplied by 3x plus 2 minus 2/3, which is equal to, open the bracket, I will have x, if you multiply 1/3 times 3x, it will be x. 1/3 times 2 is equal to 2/3 minus 2/3. So this will cancel this one. I will have only x. Means the second condition is also satisfied. So we can say yes, they are inverses. Inverses of each other. Let's take one more example. Number 3. Let f of x equal to third root of x minus 5. If g of x equal to x plus 5 to power 3. Then this is the first condition. F composite G is equal to, it is f of g of x, which is equal to, replace any x in the function f by g of x. This will give me third root of g of x minus 5, which is equal to third root of g of x equal to x plus 5 to power 3 minus 5. And we know from the properties of the root, this is third will cancel, this is 3. Because third root means 1/3. We can multiply the powers 1/3 and the 3 will cancel each other. I will have x plus 5, will get outside the root, minus 5, which is equal to x. So the first condition is satisfied. Now the second condition is find g composite f of x, which is equal to g of f of x. This is equal to, replace any x in the function g by f of x, which is equal to f of x plus 5 all to power 3. Now f of x equal to third root of x minus 5. This is f of x. And we have plus 5 all to power 3. Minus 5 will cancel 5. I will have only third root of x all to power 3. This is 3 will cancel this. I will have x. That means the second condition is also satisfied. It means these two functions are inverses. Then we can say yes, they are inverses of each other. So this is the idea of how to check whether the given functions are inverses or not. I have to find G composite G and G composite F. If both of them gave me X, then they are inverses. If they are not giving me X, then they are not inverses. And I can check this with one more example. It's number 4. Let f of x equal to x plus 5, and g of x will be 2x minus 3. And let's check, are these inverses or not? So if I check the first condition, f composite g of x, that is f of, what give me? Replace any x in the function, f by g of x. So it is g of x plus 5. G of x is equal to 2x plus or minus 3 plus 5, which is equal to 2x plus 2. But this is not equal to x. It means the first condition is not satisfied. So no need to check the second condition because one of them is not satisfied. No need to check the second one. So these two functions are not, you can say they are not inverses. So these functions are not inverses because one of the conditions is not satisfied. We have to satisfy the two conditions, A and B, F composite G and G composite F. One of them is not enough. If we suppose that one of them gave me X, but the second one didn't give me X, in that case, these functions are not inverses. The two conditions must be satisfied. F composite G equal to X, G composite F equal to X. In this case, the two functions will be inverses.